Welcome to Crashcast Java, where we dive deep into Java concepts to help you become a better developer. I'm Victor, and today we're joined by Sheila to discuss an intriguing question. Is ConcurrentSkipListMap really thread-safe?
Hi Victor, and hello to all our listeners. This is an excellent topic, as concurrent programming can be quite tricky. Before we dive into the specifics of ConcurrentSkipListMap, let's start with a quick refresher on thread safety in Java collections.
Great idea, Sheila. Thread safety refers to the ability of a data structure or code to function correctly when accessed by multiple threads simultaneously. Many standard Java collections like ArrayList or HashMap are not thread-safe out of the box. This is where concurrent collections come in handy.
Exactly, Victor. And ConcurrentSkipListMap is one such concurrent collection. It was introduced in Java 6 as part of the Java util.concurrent package. But before we dive into its thread safety, can you explain what a skip list is?
Of course. Imagine a skip list as a multi-level highway system. You have the ground-level road with all exits, then express lanes that skip some exits, and super express lanes that skip even more. This structure allows for faster navigation, especially when searching for specific elements.
That's a great analogy, Victor. ConcurrentSkipListMap implements this skip list structure in a way that's optimized for concurrent access. But the big question is, how does it ensure thread safety?
Well, Sheila, ConcurrentSkipListMap achieves thread safety through a combination of clever design and lock-free algorithms. Unlike some other concurrent collections that use locks to control access, ConcurrentSkipListMap uses a technique called compare and swap, CAS, for most of its operations.
That sounds interesting, Victor. Can you elaborate on how this compare and swap technique works?
Certainly, compare and swap is like a careful juggler. Imagine you're trying to replace a ball in someone's hand. You'd check if they're holding the ball you expect, and only if they are, you'd swap it with your new ball. If someone else changed the ball in the meantime, you'd start over. This approach allows multiple threads to make changes without explicitly locking the entire data structure.
That's a clever approach. So, does this mean ConcurrentSkipListMap is always the best choice for multi-threaded environments?
Not necessarily, Sheila. While ConcurrentSkipListMap is indeed thread-safe and provides good performance for concurrent access, it's important to consider your specific use case. For instance, if you need a sorted map with high concurrency, ConcurrentSkipListMap is excellent. However, if sorting isn't a requirement, other options like concurrent HashMap might be more suitable.
That's a great point, Victor. It's always crucial to consider the trade-offs. Speaking of which, are there any potential drawbacks or common pitfalls when using ConcurrentSkipListMap?
Absolutely, Sheila. One thing to keep in mind is that while individual operations on ConcurrentSkipListMap are atomic, compound operations are not. For example, the check-then-act pattern, checking if a key exists and then acting based on that check, isn't atomic unless you use the map's atomic methods like putifabsent or computifabsent.
That's an important distinction, Victor. It sounds like developers need to be mindful of how they use ConcurrentSkipListMap to ensure they're leveraging its thread safety correctly. Are there any best practices you'd recommend?
Definitely, Sheila. First, always prefer using the atomic methods provided by the class when possible. Second, be aware that iterators returned by ConcurrentSkipListMap are weakly consistent, meaning they may not reflect the most up-to-date state of the map. Lastly, remember that while ConcurrentSkipListMap is thread-safe, the objects you put into it may not be, so ensure your key and value objects are immutable or properly synchronized.
Those are excellent tips, Victor. As we wrap up, could you summarize the key points about ConcurrentSkipListMap's thread safety for our listeners?
Certainly, Sheila. ConcurrentSkipListMap is indeed thread-safe, using lock-free algorithms and compare and swap operations to ensure safe concurrent access. It provides good performance for concurrent reads and writes, especially when you need a sorted map. However, it's important to use it correctly, being mindful of compound operations and leveraging its atomic methods when necessary.
Thank you, Victor. That's a great summary. For our listeners who want to dive deeper, here are 3 advanced topics related to ConcurrentSkipListMap and thread safety in Java. 1. Lock-free algorithms and their implementation in Java. 2. Memory consistency effects in concurrent collections. And 3. performance tuning for highly concurrent applications.
Excellent suggestions, Sheila. Those topics will certainly provide our listeners with a deeper understanding of concurrent programming in Java. Thank you all for tuning in to Crashcast Java. If you found this episode helpful, please subscribe and join us next time for more Java insights.